All right, so last time we learned that in order for an element to be the same, it has to have the same number of protons. If you have one proton, you're a hydrogen, two protons, you're a helium, and so on and so forth. However, while all atoms of the same element have the same number of protons, they don't always have the same number of neutrons. So for example, your hydrogen, maybe it has no neutrons and one proton, or one neutron and one proton, or two neutrons and one proton. And so when you're the same element, but you have different number of neutrons, you are called an isotope. Isotope. So an isotope is the same element, which means that it has the same number of protons, but a different number of neutrons. So for example, if it has one proton and 0 neutrons, it is hydrogen. If it has one proton and one neutron, it is still hydrogen. It is now just a different isotope of hydrogen. So some elements, such as beryllium and aluminum, only have one isotope, naturally occurring anyways. While others, for example, sodium and chlorine, have 2 or more isotopes. So it really just depends on what element that you're talking about. And so the number of neutrons is important to a compound. And so we have this as the mass number, the mass number. It's the symbol of a capital A. And so the mass number is equal to the number of protons plus the number of neutrons. So it's a sum of the protons and neutrons. So for example, if we took a look at magnesium on the periodic table, if we find magnesium, Mg, it's right over here. Magnesium always has 12 protons. If it doesn't have 12 protons, it's not magnesium. But we can have different isotopes of magnesium. And there's different ways we can write these isotopes. So for example, we can have something known as magnesium 24. And so this 24 is the mass number. And so magnesium always has 12 protons. And if it has a mass number of 24, that means that the sum of the protons and neutrons is equal to 24. So if it has 24 total and 12 are protons, that means that the other 12 are neutrons. Another popular example is magnesium. You can give the symbol instead if you'd like, magnesium 25. So this has an atomic number of 25, but still 12 protons because it has to in order to be magnesium. But this time we have 13 leftover particles, and those 13 are neutrons. Or even magnesium 26. So you see magnesium has at least 3 isotopes. Magnesium 26 will have 12 protons and then 14 neutrons. So this is one way to write isotopes. Another one is through what's known as the isotope notation. So it goes something like this. There's something in the center. This is the chemical symbol. So this would be your C for carbon, Mg for magnesium, or whatever. You have a number up here. That's your atom or mass number. And so that is the number of protons and neutrons. And then you have a number down here that's Z, your atomic number. And that's just the number of protons you have. This number is often omitted. So it's not shown because the information is redundant. If you have the chemical symbol, you know how many protons you have. And so it doesn't really need to be stated. So for example, let's take a look at neon. Different isotopes of neon. So go ahead, pause the video and tell me how many protons and neutrons each one of these neons has. Okay, so hopefully you pause the video, right? This number down here, bottom left, that means that you have 10 protons. The top left number is protons plus neutrons. So if you have 20 total and 10 of them are protons, that means 10 are going to be neutrons. And so again, we have neon again, so 10 protons. This time up here, we have a number of 21. So 10 are protons. That means that there's 11 left over. So 11 neutrons. And then in this situation, you're not given the atomic number. But if you use your periodic table of elements and you find neon, you'll see that neon always has 10 protons. And so you know it has 10 protons. And then the mass number is 22. So if you have 10 protons, that means you have 12 neutrons left over. So again, the number of neutrons here is equal to the atomic number, or the mass number, my bad, the mass number minus the atomic number, right? And that makes sense because the mass number is protons plus neutrons. The atomic number is just the number of protons. And so when we do the math here, these number of protons would be cancel out, and then you'd just be left with how many neutrons you have left over. Overall, isotopes aren't terribly interesting. Isotopes behave almost exactly the same as each other. Right, so something like a neon 20 versus a neon 21 would not have significant differences from one another. Overall, they would behave approximately the same as one another. And so what that tells us is that the number of neutrons has little effect on the properties of an element. It's really the number of protons and electrons that controls most of the properties of an atom. There are obviously instances where isotopes behave differently and it does become important, but that's beyond the scope of this course.